In this section, we're going to take a look at how strings are represented in C. Now, if you think back to when you use Java, Java already comes with a string class, right? A string type. And we can do a lot of stuff with it very easily, right? We can use double quotes to create a string, right? You can use a plus symbol to concatenate strings together, right? It's actually, an object, right? So we can do a dot and we can get all kind of information on it. It's very kind of straightforward to use. Now C, well, we know C doesn't really have support for classes, so we're not going to have that luxury. Now C itself doesn't actually even have any sort of data type for strings. Instead, the way C is going to work is C is going to say that strings are essentially arrays of characters. And so this is going to be a little bit of a different experience for us. Okay, so let's talk about how we'd actually define a variable to contain a string. Now there are two kind of ways we can do that. Well, the first way is not really defining a string, it's defining an array of characters. But let's read through this. All right, so here I've written char, right? So I know that I'm typing something as char, right? My new variable, S1. And notice it's an array, right? And kind of at a glance, that should make sense because, oh, well, if I'm trying to represent a string in a programming language, string is made of characters, a bunch of them, right? Sounds like an array, right? I have multiple things in there. So, a character array makes sense. And then over here we have this static initializer list, right, with the curly braces. And in there, right, we have our ALPHA, right? Because what we're trying to do essentially is store those 5 letters into this array. Now this, as it stands, this first part here, this is just creating an array of characters that contains the word alpha. But it's really just an array of characters. It's not a string. The reason for that is that arrays have to look a certain way, right? So there's actually kind of this definition where in C we say, okay, something like this, right, that just has these letters, that's just an array of characters. But when I have those letters followed by a null, that makes it a string, right? So we're actually going to define that all strings in C are simply arrays of characters that are null terminated, right? So there's this character at the end that basically says, this is where this thing ends, right? Because it's valuable for us to know, okay, this string contains these 5 letters, and then this is where it ends, right? Because in C, we don't have the ability to do things like, dot length, right? Arrays aren't objects like they are in Java, so we don't have the ability to look up information like that. Instead, the way we can kind of designate how long this thing is say, this particular variable, it contains all these different letters up until the null terminated, right? So it's a way of telling us how much data is in there. Now, over in the declaration syntax, right, if we do actually want to declare a string, what we write is this, right? The first part is going to look the same, where we say a char variable, bracket, right, to say array. Then we have equal, and then notice we have alpha and double quotes. So the double quotes here, right, is kind of is C's a little bit of concession, right, to the fact that we need to support strings. And so what those double quotes are going to tell your compiler is to say, okay, what they want to do is they want to store the string alpha into S2. And so instead of actually just putting that ALPHA, right, as 5 characters in there, internally what will happen is you'll get those 5 characters plus that null terminated, right? So using that special double quote syntax is what's going to tell C, create a variable, create a character array that is containing a string, right? Again, right, these are both character arrays, right, S1, S2, but because S2 is created the way it is, it has that null terminator at the end, right, very important, and that makes it, by definition, a string. So jumping down here to the end, it's actually possible to use the syntax for creating strings to assign things into variables that are maybe a little bit too small. So over here, right, we have these 2 alphas again. And here, right, we have a word with 5 letters in it. We know if we wanted to talk about strings in C, then that means there should be a null character at the end, right? So maybe that's a total of 6 characters there. But then over here, right, we see that we have this S3 and S5, and those 2 variables, one of them is of length 5, one of them is of length 4. So for example, S3 only has space for 5 characters, so it's just going to take the first 5 characters here, right? ALPHA. And what will happen, right, is because I don't have memory available, it's not going to put that null character anywhere, right? Even though we have our double quotes to indicate to C that we want to talk about a string, and strings are supposed to end with null terminators, because we didn't make enough space in our variable, it's just not going to appear, right? So over here we can see in our picture, right, we're missing this over here, right? Previously, right, we had our null symbol at the end, but here it's just missing. Okay, so this is going to be bad. We're going to actually see on the next screen why exactly this is bad. Another example, right, where it could be problematic is even smaller, right? We say we created a variable of length 4, and we try to store alpha into it. Well, in this case, right, we get ALPH, right? We lose both that null at the end and we lose that A at the end. So 2 missing spaces, even worse. Now you might think to yourself, okay, maybe that's not so bad because now I just have a shorter word, or I just have an array of characters. But it's going to be actually a little bit worse than that because inside of our program, right, our program is actually going to treat, right, these variables S1, S2, S3, S4. All these should be treated as if they are strings. And you'll see why that's important in a moment. So let's take a look at the following program. Now the first stuff is pretty much boilerplate to us, right? We're used to our includes, we're used to our pragma, right, our void main, curly braces, right, to start and stuff. But what this example is going to be is it's going to be us creating a couple of strings, a couple of, well, I should say well-formed strings and a couple of malformed strings, and trying to display them. And let's just talk through the code and then we'll take a look at the output. So here, right, I'm creating 3 variables, S, S1, S2. So S, right, is going to be 6 characters long, so that should work for us. S1, right, we're not defining the size ahead of time, we just have the brackets there to say, oh, I'm going to create an array. And then I'm going S1 equal hello. Right, so that has the effect, right, of basically saying, okay, S1 is going to be, created to be an array that's large enough to hold those 5 letters in the word hello plus the null, right? So S1 will be an array of 6 characters, and then those 5 letters are going to be stored in there, as well as a null at the very end. And then I guess glancing again to S, right? S we said was of length 6, so that's actually going to be an array, right? That's big enough that we could potentially even copy that entire word hello in there. Okay, so that's what we have for these 2 variables. Now we also have a third one here, S2. S2 is of size 5, and we notice over here we're trying to store in the word world. Well, world by itself is 5 characters, so that means I'm probably going to be able to store that W through D into that S2 variable, but I'm not going to have space for a slash 0, right, or that null character. So that maybe is a little bit, a little bit odd, shall we say. I'll have kind of S2 as just an array of characters, not as a string itself, because strings require that null termination. Now let's take a look at the code and try to see what's going on. Now a couple of these lines are straightforward. First, basically we have a loop, right, from 0 to 5. And then that loop, what we're doing is we're saying, okay, go to that S1 variable that stores the word hello and print out each character in there, right? So it should print out H-E-L-L-O, right? We're just looking, or that I variable, right, is changing, so we're going and touching each of them one at a time, print out each letter, should have the word hello at the end. Notice, right, we have in our printf, right, our formatted output, notice we have the %C, because an %C is saying, okay, I'm going to print out a character, right? So it's going to print this thing out character by character. So that should be fine there. Let's see. If we look down here for the second for loop, right, kind of the same thing happens again, 0 to 5, printing out S2, right? So that should have the effect of going and printing out world, right, 1 letter at a time, similar to how hello was printed out 1 letter at a time before, right? Basically, each time we're saying print out the first 5 letters. Both of those words are 5 letters, so it'll print out both of those words, right, for each of those respective places. Now, let's take a look at the printf statements. The printf statements, what we have here, right, more format output. Notice here we have our %s. So that's basically going to be our placeholder to say, okay, a string should go there. In this case, right, the string over here is S1. So this first printf, right, should have the effect of printing out that word hello. And it should be fine. There will be, S1 equal hello, comma, size equal 6, right? So that's the size of the array. So that shouldn't be too bad. Now, our issue or our concern is going to actually be on this 4th line here. So on this 4th line, what this is saying is S2 equals %s, comma, size equal D, and then over here we're passing S2. But here's a problem, right? S2 is meant to substitute in for this %s over here, but we said %s, that should represent a string. But S2 isn't actually a string because S2 only had space for 5 characters. Well, the 5 characters were just for the ones from the word world, and so I don't have a null terminator at the end. If I don't have that null terminator at the end, then I can't say S2 is a string, right? It's just an array of chars. And yet I'm telling printf, go and treat it as if it's a string. So that's going to end up giving us a little bit of trouble. And actually, let me go ahead and bring up the kind of the image that goes with that. So this is the output, right? So we have over here kind of what we talked through, which is, print out the word hello, print out the word world, right? And the line we're talking about right now, right, this line over here is the one that generates this here, right? This S2 equal, right? And you notice over in our output is we have the word world, a bunch of random symbols, and then the word hello, and then our comment. right? So what that's basically doing, right, is it's saying, okay, the inside, the way C is working is it went to that S2 variable and tried to print out the contents of it, but the problem was it uses kind of this internal rule where it says, okay, keep printing the characters at this memory location, right? Because S2, right, S2 is some variable stored somewhere in memory. There's a bunch of letters there that represent a word or a string, and printf, right, is going to that place in memory and it's printing out those characters one at a time. But basically, it's going to keep on printing those characters until it sees a null, right? Because that's the format of a string. That's how it knows it's printed out the entire string. Well, in this case, right, world doesn't have a null at the end, so it goes and prints stuff past that, right? So those little other symbols here, right, this is basically all the data that's stored right after the word world in our system memory. Now, eventually, because of the way memory is laid out, in this example, basically world is laid out before hello. So basically, we go through and we display all kinds of this gibberish data, and then we get to the word hello, and then the word hello, well, that is actually the string from earlier, and that is properly terminated, right? So at the very end of hello, there is a null character, right? And that's fine. That's actually when this print statement here will stop printing stuff out, right? Because it'll have the ability, it'll then recognize it as, oh, I've printed out an entire string because I've seen a null character. Depending on when we run this program, we get all sorts of different outputs. Again, the idea is it'll print, all the things in memory starting at S2 up until it finds that null, right? Because that's what it's expecting of a string variable. All right, so last line here, we're using kind of a common library function over here that's called strcopy. Sometimes you'll be strcopy_s, depending on whether your compiler wants this version or that version of it. What this is a function that will copy all of the contents from one string to another. So in this case, we're going to end up copying from S1, which had the word hello, to S, right? And S, fortunately for us, is of size 6. So there's actually going to be space to put all those 5 letters in the word hello, plus a null terminator at the end. So basically, we'll make a copy. And at the end, right, we have another print statement, which is going to do kind of the same stuff as before, where it's going to go and try to print out that S variable. S, fortunately, is basically a copy of that hello array/string, right? And that thing was properly set up with a null at the end. So there's no really issue trying to display it, right? It works as we expect. We get our output, S equal hello, comma size equals 6.